Okay, so your assignment in class was pages 28 and 29. Not everybody got through 29, which makes sense. But tonight I'm going to show you 29 and 30. So you have sort of like the video answer key to 29, and then class notes on page 30, which you really couldn't do without my notes. So you have to watch the video. Anyway, beginning of 29. Again, there are bottoms labeled here. When you do the bottoms, you can't do the side splitter theorem. So you can't just say something over something equals something over something, because you're dealing with bottoms. So in that case, you have to redraw the triangles. So I have the small one and the big one. Just make sure you know the side of the big one is 15, which that means you could have 12 over 14 equals 15 over x. You could also have 12 over 15 equals 14 over x. Both of those would work. Then you have 12x equals 210. You divide both sides by 12. You get x equals 17.5. This one's a little different in that it tells you that these two segments are the same, meaning that has to be the midpoint. If those lines are parallel, and that's the midpoint, then you have a mid-segment, which we learned about a couple of months ago, which means this is half of this. So this would have to be 6 right here. So a little bit of a shortcut there. Here we have a small and a big again. So here's a small triangle, x and 4. Then I have the big triangle. I'm redrawing it. And I have 13 on the bottom because the total bottom is 13. So now I can just set up the proportion. I went side, bottom, side, bottom. You could also go 6.75 over x equals 13 over 4. Either way, when you cross multiply, it will be the same. So we have 13x equals 27, and when you divide both sides by 13, you do get a funky number here. It is 2.07 or 2.08 if you round it off to the nearest hundred, so however you rounded that off, don't be surprised, it is a wacky number. Letter D. I have small triangle, 18 and 20, and I have the big triangle, which is 18 plus x over 25. That entire side is 18 plus x. So when I set up that proportion, I'm going to go 18 over 20 equals 18 plus x over 25. When I cross multiply, I get this. When I distribute 20 times 18, 360 plus 20x. Over here I have 450. I'm going to subtract 360 from both sides. I have 20x equals 90. Divide both sides by 20, and x comes out to be 4.5. This one really has no math. It's just testing to see if you notice something. There's an angle bisector here. That angle's the same as that angle. That side's the same as that side, which means we have an isosceles triangle. So that side has to be the same as that side. So x is 7.5. This one here is similar to the one we did before. You have to notice this big triangle here. And I can find x, the entire side, by doing the Pythagorean theorem. 8 squared plus 15 squared equals c squared. So 64 plus 225 is 289 is c squared. Your last step in the Pythagorean theorem is to take the square root. So x is 17. So now that I have some more information on the side here, I can use the side splitter. I'm going to go the entire thing over the bottom equals the entire thing over the bottom. So it's going to be 15, the entire top, over just part of the top, equals the entire other side over just the part I'm looking for. So I have 15y. And at that point, when I divide both sides by 15, I get another crazy decimal, 5 2/3 or 5.6 repeating. Okay, consider page 30, class notes. So pretend your homework's done, and now you walk into class and I'm teaching you essentially something new here. Remember me saying at some point not too long ago that scale factor is always the image divided by the pre-image. You have to remember that. The scale factor is image over pre-image, which basically means the new one over the old one. So if you're going from AB to CD, then that's got to be old and that's got to be new. So wherever you go to is your newer place, and wherever you came from is your older place. So this is my old, and this is my new. So the scale factor there would be new over old. So the scale factor here is 8 over 3. Just leave it just like that. The distance 8 over the distance 3. 8/3 times bigger. Now what if you reversed it and went the other way? What if you went CD to AB? Then these two switch. And now it's 3 over 8. So if I wanted to go the other way, it's a shrinkage of 3 over 8. So it's always your new over old or image over pre-image. Now in this next problem here, it doesn't give you any numbers. That's why it says exact scale value, because it wants you to use notation instead of numbers. No numerical values are used here. So from MN to TS. So that's my old pre-image. This is my new image. My new one is TS. My old one is MN. There's my scale factor. TS over MN. I just didn't have any numbers, so I used their full names. What is the general pattern for describing a scale factor? We have that right here. Image over pre-image. Now I'm actually going to stop right there. This is the beginning sort of similarity proofs, which we're going to come back to several days away. So we're going to stop right here. We're going to start a newer topic tomorrow, but I wanted to cover scale factor right there. And have 28, 29, and up to right here on 30 done for tomorrow.